So thank you everybody for being here. I'm so happy to have the chance to talk about some thing. And today I want to start a journey into the declarative world. And in particular, with this talk, I want to give you a high-level overview on how things work in the declarative side. Because I think that if you understand how things work in general, then you will be able to pick any kind of framework of your choice. So not only Compose, but you can easily jump on, for example, SwiftUI, React Native, Flutter, whatever framework that you have to use. All right, so first of all, I'm going to quickly introduce myself. I'm Marco Gomiero. I'm based in Venice, and I work remotely for Develop. And in my free time, I'm also one of the co-leader of the Google Developer Group Venice. And these are my social handles if you want to follow me. I'm pretty active on Twitter, and then I have also a blog. All right. So let's start, and let's assume that we have to build an application, a client for reading news from Hacker News. So first of all, we need to download the news. So we need to show to the user a loading state in which the user waits for the news to be downloaded. Then we have to show an error state if something goes wrong, because shit can happen. And then we have also, of course, to show all the news ready to be read by our users. So how to build this kind of application with an imperative style? Well, we have to do many things. First of all, we have to define our view. And to define it, we have to create an XML file with all the different components that we want inside our application. So in this case, we need to show in a screen, we need to show a loader, we need to show the error message, the error button, and of course the list. So in the same file, we throw different components. Then we have to bind the XML with the actual code. So we need to retrieve the different view instances of the different components. So we have to call the famous find view by ID method, or in this way, or in a different way if we are using the view binding. And then we have to store this reference to be used later in the code. After that, almost every application have a list, so we need to define some code to handle our recycle view. So we need to define an adapter with all the different methods, provide and populate the list. Then we have to add finally some logic to make our application react to the changes of the state. So if the state is the loading state, we need to show the progress bar and hide everything else. Then if the state is an error state, we need to show the error message and the retry button and hide everything else. And again, for the success state, we need to show the recycle view and hide everything else. And we have to write a lot of boilerplate, a lot of boring code. And this code, since this code is boring to write, it will be also more error and bug prone. And that's mainly because there isn't a single source of truth for in the application. We have some truth inside the view model, inside our logic. Then we have some truth inside the UI. Another piece of truth inside the XML, and again another piece of truth inside the the code of the UI components that we are using. So for example, the switch, the spinner, and whatever. And then another possible situation of error is the view instances that we have stored before, because if something bad happens in the application and that view is not in the UI hierarchy anymore, then we will have a beautiful null pointer exception. And so all these things is hard to maintain. We don't have things clear, and in order to fix maybe a bug, we need to navigate between different places in the application to understand where the problem is. And this is the imperative style of building user interfaces. And the imperative style basically make us write what we want and how we want. So we need to write. So if we have an application, a screen like this, so for example, the loading state, and then we want to move to another state, for example, the success state, we need to write the code that describes the state A and the state B, and then we have also to write the code to move from state A to state B. And this is painful for the reason that I've told you before. And it would be amazing if instead we will have a magician that automatically move and transform our state from A to B. And this magician is one of the key components of the declarative pattern for building user interfaces. And basically, in the declarative things, in the declarative pattern, we have only to specify what we want, not how, because it's a matter of the magician, not a problem for us. Okay, so it seems okay, but I want to know a bit more. So we can describe the entire declarative thing with this mathematical equation. So the UI can be viewed as a function of the state. And for now, you can take as granted this function. Then during the talk, we will understand the different pieces. But to understand it, let's start from the state. And the state is basically a description of the UI that we want right now, so in this specific moment. So for example, the state A that we have seen before is the state associated with the loading screen. And instead, the state B is the state associated with the success screen. And the two states are independent between each other. So the state A doesn't know anything of the state B and vice versa. And then there aren't any reference from the state A to the state B and from the state B to the state A. And then if there is a change, the UI will be redrawn because a state is highly coupled to a specific UI. And this redrawn, of course, is done with optimization because we don't want to waste resources. So if a specific piece of our UI is not changed, it is not necessary to redraw it. And all this thing is automatically managed by the magician, so we don't have to deal with complicated code to make the change performant and stuff like that. It's all automatically. Okay, so how this magician make things works? The magician creates an abstract representation of the UI before rendering it. So, for example, starting from a screen, it generates a a representation that usually is a tree-like structure, because the UI is can be easily represented with a tree structure. And then if there is a change, so the state has changed, the magician creates a new representation. And so it creates another tree, and then it uses something magical. So when we see that there is something magical, it means that there is an algorithm that does things. And this algorithm computes the differences that there are between these two representations, and then it renders only the differences, of course, if there are any. Otherwise, it will don't do anything. Okay, so but how things works in details? Well, it depends. It depends, and it depends on the specific implementation of the framework that you are using. So now I will give you some example of the different different framework, and I start from React because React was one of the first framework on going declarative, and it's one of the opening, and it opened basically the road for everyone. So React and React Native, because React Native is basically the same of React. On React Native, the system creates a virtual DOM as a representation of the UI. So, for example, from this button, it creates a representation like this. So a JSON with that describe a tree structure, and in this JSON there are all the different properties of the button. Then the system computes the differences between a representation and another by using an algorithm called reconciliation. That it is basically a 3D thing algorithm, and it is a linear algorithm, so the performance are great, and then it does its magic to understand the differences. But of course, you don't need to know the internals of this thing. It's okay to use it without knowing everything. But if you are interested, because this thing can be fascinating if you like it, of course. And if you are interested, there is a very well-made documentation on the React website. All right, Flutter instead uses a representation very, very similar, but it is element 3 as a representation. So, for example, from this menu, it creates a tree like this, and every node in this tree is a widget. And in Flutter, everything is a widget. Every piece of UI is a widget, and also the characteristic of the UI component, like the padding, is a widget itself. And so the system builds this kind of tree, and when a node changes, when the state changes, the correspondent widget and the correspondent widget change. The node is marked as dirty, and then the system will redraw the child and the node and all their children. So on Flutter, there isn't a 3D thing algorithm, but for each node, the system checks the node and the children of the node with a linear algorithm. So again, performance are great, and then it understands how to render things. Again, if you're interested, I point you to the documentation that also for Flutter is very good. Okay, Jetpack Compose instead uses the slot table as a representation of the UI, and the slot table is a data structure that is very similar to the gap buffer that it is used on text editors. And basically, a slot table is, you can think of a slot table like an array with cheap insertion, lookups, and deletion. And so, in this case, Jetpack Compose will put every node, so every piece, every composable function inside as a node inside that structure, and then it does some magic, and it understands if a node is changed, and if a node is changed, it re-render it. Again, I've described it in a very quick and dirty way, just to get the high-level understanding. But if you're interested, there is a talk by Leland from the Compose team that is very, very good, and it describes very well how things are is doing. And there is also a blog post about it, and I link it. Next on the slide. All right, but how we can define a piece of UI inside our application? Well, again, it depends, but it depends. But things are very, very similar. So again, now I will tell you how things are done in the different framework. So starting again from React, a piece of UI is a component, and we can create a component with like a class, and basically a component is a class. And this class has a render method, and inside the render method we return all the code that it is necessary to show what we want. And on React Native, on Flutter, sorry, instead there are widgets, and a widget, like I told you before, is everything on Flutter. And as you can see, widgets are very, very similar to components. And so a widget is a class with a build method, and inside the build method, we return what we want. On Jetpack Compose, instead, we have a composable function, and a composable function is a Kotlin function with a special annotation. And then the compiler will transform this function into a piece of UI that is shown in our application. So in this on Jetpack Compose, we don't have a class, but we have a function. And the same on Swift UI, that is the declarative pattern for building UI on iOS and macOS. In Swift UI, we define the view with the Swift struct, and we have to return our UI hierarchy inside the body function. Inside the body parameter variable, not function. So there are different ways of doing things, but at the end, all the different representations are very, very similar. And so we can abstract this definition of the UI with a mathematical concept that is a function. And this function is, of course, a function of the state. And this kind of function must have a specific feature to be used as a description of the UI. And this function has to be pure. And a pure function is a function that returns the same value given the same input, and also it has not any kind of side effect. So let's try to understand what these two lines means with an example. So in this function, we have two inputs, two parameters, a and b, that are two integers. And then this function makes a manipulation of these two inputs and returns another value that is the sum of the two inputs. So it sums. It makes a simple sum. And it does not any side effect. So this function can be considered a pure function. Then we have this function, and this function takes as an input two parameters, an instance of the bank account of the bank. Oh, sorry, it's the first time that I saw this typo, and it's not a back account. My mind has thought it as a bank account, but whatever. So let's imagine that there is a bank account input and an amount, and then this function modifies the balance that is contained in the bank account, and then it subtracts from that balance the amount that is provided as an input. So in this case, the function is doing a manipulation of the input, but it does not return a new input, a new value, but it modifies directly the input. So this is bad. This is very bad, and this is not a pure function. And that's because this function causes a side effect on the bank account variable. And for example, if this variable, this instance of the bank account, it is used by someone else in the application, then this change maybe can make things bad for the other actor in the game, because maybe it doesn't expect a change. Okay, so in our specific case. And another things very important and a very good characteristic of the pure function is the fact that we can test it in a very good way, because we have the same. We know that the function will never change its behavior. So back to our declarative talk. In our specific case, we have a function that takes some inputs, and we want to return it a piece of UI. So in this case, we have an input that, and the input is the state, and the result is the UI. So maybe now you are remembering the function that I saw, the equation that I showed you before, and that's it. That's what this function this function mean. And as I told you before, we cannot modify directly the state, because the state is highly coupled to and specific to a UI. And if we need to generate a UI, a specific UI from a specific state, then we can modify it before returning a new UI. Because if we modify the state before returning the UI, then we will trigger another recomputation, because the state is changed and then we need a new UI, and so on. So if you will do this, then you will trigger an infinite loop, and the memory will end and the application will crash. And I've tried and I've done it, and it's not a beautiful thing to do. So how we can modify and react to the state changes? Well, let's try to understand with an example. And so let's assume that we have this check and this switch, sorry, and then we have to write the piece of code that manages this switch. So here we have it. This is the code to handle the switch, and don't try this at home because this is a mix of Flutter, Compose, and this is a totally made up example that of course doesn't work, but it is only helpful for the explanation here. So so let's assume that we have this switch inside our application. So for example, at the bottom of the UI, and this graph is there's a representation that the magician built of our UI. So at the topmost level, we have the state holder that it is whatever we want. So maybe maybe a class that writes things on the network, on the database, on a text file, on whatever we want. Then we have all the different UI components, and then at the bottom we have our switch. So to make our switch on and off, we have to provide a Boolean value, and that Boolean value is stored, is retrieved and managed by the state holder. So we need to pass it from the state holder down to the switch component in order to enable it. And then when the user checks the switch, we need to update that value. So we cannot update the value inside the switch itself, because otherwise bad things will happen. But then we need to provide we need to send the change up to the state holder, and then the state holder does its things. So it writes to the network, to the DB, to the text file, whatever, and then it notifies again back the switch. So we have that the state goes down to the tree of the UI, and instead events goes up. And this is basically the unidirectional data flow. And so with the declarative, we have to architect our UI and make and embrace the unidirectional data flow. So we have to bring the state holder and the classes that manage the state to the at the top of the component. So on which level? Well, it depends on the application. Maybe in some situation it is good to have a global state holder for everything in the application. Sometimes it is better to have a state holder for a specific screen, for a specific component, whatever. It depends on the implementation. And then in this way, you can inject the state inside the component, and then you will have a callback, a lambda, to update the value. And in this way, our components are completely independent. We can use them in different parts of the application, and also we can test it easily with fake data, because all the things needed for its behavior are injected. All right, so another thing interesting before closing up about the declarative thing is the fact that we can use composition over inheritance. And this thing is very interesting and very helpful if we have to build a complex UI. So for example, let's assume that we have a container that extends the Android view, and then we have a news card that again extends the view. So and then you have to build a news card container. So how you can do it? Well, it's complicated. It's a difficult task, because you cannot extend at the same time from the news card and the news card and the container. So maybe you have to build something intermediate. maybe a wrapper, maybe something, then you have to inherit all the different function from the different components. So you need to provide the implementation of things from the news card and from the container. Then if something changes, it is a mess and whatever. So with composition, otherwise it will be more easily. And with composition in a declarative framework, all you need to do is put a container inside the card, and then you will have a container inside a news card, and that's it. You don't have to inherit things from the behavior of the news card or from the news container and deal with them. That's it. Clear and easy to do. Okay, so now I want to summarize the talk by going back to the example that I introduced at the beginning. So at the beginning we had this example with all the different reaction to the state, and then we have to make our view react to the state. So we have to check if the state is loading, if the state is error, and if it's a success, and then make our UI react. So if the state is loading, we need to make the progress bar visible and hide everything else. In the error state, we need to show the error button, the error message, and hide the recycle view and the progress bar. And the progress bar. And if you see on the slide, I forgot to hide the progress bar. And this was, I'm telling you the truth, this was, I not made up this mistake just for the sake of the talk, but it was a real mistake. I noticed it when I made the slide, and then I say, oh, look at that. It was a perfect explanation of why imperative gave us some headache. And in fact, hiding the progress bar here was not. It was an easy task because all we need to do is say view.gun, but it was very easy also to forget to do it because you have a bunch of view.something and you forgot to do it. And again, we have to do the same thing for the success state, and that's it. And this was in the imperative style. On the declarative, instead, all we need to do is check the state, which state is it, and then we simply return the view that we want, without worrying about hiding things and hiding stuff. All is done automatically by our so beloved magician. All right, and this is the example that I show you on the slide is available on my GitHub. I wrote a sample with declarative and imperative on Android and iOS, so with XML and Jetpack Compose on Android and UIKit and SwiftUI on iOS. And then as a bonus, I've added an example with React Native and Flutter. And as you can see, and spoiler, the thing that I hate the most is React Native. And sorry, I have to remark it every time. Joke aside, if you will see the repo, all the declarative implementation are very similar between them, and you can jump between them without having too much cognitive overload. And in fact, my approach into declarative was was similar to this, because I started with React Native for work reason. Then while learning React Native, I started also learning Flutter because I wanted to do it. And then after learning Flutter and React Native, I jumped into SwiftUI, and I was a little bit of, I found myself at home, because only some variables has changed, and then the concept is very, very similar. And then on Jetpack Compose, again, I find again myself at home, because I already know what I wanted to build. And so that's why at the beginning of the presentation, I told you that if you understand the high-level concept, you will be able to jump between different frameworks, if you want, of course. All right, so now let's jump to conclusion. And Declarative, we can summarize Declarative by saying that on Declarative, we describe only what we want, not how we want. And in this way, we have to write less code. And if there is less code, of course, there are fewer bugs, because no code, no bugs. And of course, in this way, things are more maintainable and scalable. And things that I want to remark is that this is a totally new paradigm. We are in the middle of a transition. And getting into this paradigm requires time, requires some time to get used to it. So don't worry if you feel lost at the beginning. Take your time, try it, and step by step, you will realize that it is much better and so much an improvement rather than imperative. And another thing that I want to say is that you don't need to know the internals of this stuff like I've done. I've done it because I like it to dive into internals, because that's how that's what I like. But of course, you can pick a framework and look how it works on the high level, on what you need to know to make it works, and whatever. Going declarative does not require to know what things are, how things are working internally. All right. These are some useful links in the bibliography that I've used to build that talk. And of course, I will share my slides on Twitter, so make sure to follow me to get the slides. And with the slides, you can check the links, of course. And thank you. Again, feel free to reach me here in the platform if you have some question. I will be around for the time that this thing is up. Or if you want, you can feel free to reach me out on Twitter, drop me a DM, my DM are open, and also follow me on my blog where I write this kind of thing. So thank you again.
Thanks. Great. If you pop over to the Q&A section, it looks like we have a couple of questions here. Some might will filter in, but I'll pop off and let you answer those, okay?
Okay. All right, so we have a bunch of questions. The first one, if a screen is a stateholder, but we need to pass argument lambdas to 3 to 4 level below switch component, do we have to pass the argument 3 to 4 times from parent widget to bottommost widget? It depends. It depends on how you architect things, and you can declare something at the topmost level, and then you have to pass it around. or you can define something at a much lower level, so you can be more specific on the specific widget. So, for example, at a developer, we have the iOS application, and we have a state that is general for the entire application. So, for example, if maybe you can think of if a user is logged in, or if the theme of the application that the user chooses, and this stuff. And then we have to inject things around to make, for example, a component react to the specific thing. Then we have a specific screen that have a specific state, and then we have to inject stuff only to the specific things of that specific screen. Sorry, I've said too much specific in this phrase, but there is not a rule of thumb to follow, but it really depends on the implementation. What I try to follow is that another thing. You can leverage dependency injection to do so. So you can have more easier thing. The rule that I try to follow is to make component or specific component, or more general one or more specific one. It depends. We're not trying to have for example, a card that is okay for every application, for every piece, for every zone of the application. But maybe you can differentiate, and then so you can inject different things independent on the situation. Okay. What would be ideal? Passing a view model or a state to your declarative UI? Okay. Well, the most ideal and top things will be to inject a state, because then you can kind of unit test your UI component, because and so you don't have to pass the entire view model. But again, this is not a strict rule. It depends on your situation. But if you can, try to inject only the state, so things can be more reusable and more testable. And about this topic, there is a great documentation provided by the Jetta Compose team. I think that, if I'm not wrong, it's the last link that I put in the slide, and here it describes very well how you should do things. Of course, these are always there are not rules that you are forced to follow, but there are guidelines. Of course, you can do whatever you want. Okay, are there any analysis between slot tables, diffing algorithms, and slot tables to know which mechanism is better to manage UI and its state, like which one is better and why? I don't know if there are analyses. Well, another thing to know is that you don't have to know these things for build a UI, of course. But you can find more things, not comparison, but more things about the architecture used in the different framework on the documentation. And but I don't think, and I don't found any analysis between the different implementation, because I think that also it's not in the scope of the people on, for example, the Jetta Compose team and React team to write a comparison between the two. I think that it is better to explain how you do things, and maybe there are some comparison. It will be interesting to do, but I don't know. Okay, so can UI, another question. Can UI function return something other than emit UI? The quick answer is no, because UI functions are specifically built and used only for returning UI, and you should do so to avoid kind of bad things. It is a good thing to have a thing that does one thing, and one thing that is specific to its context, not a function that returns UI and does many other things. Because of course maybe you can have, but it's not a good thing. Okay, I think that we have other time to answer if you have some questions. Okay, another question. Using XML for layouting, there were a source folder for different configuration. How would you differ between phone and tablet widget Compose? On Compose, you have. I never yet tried to different between right now, but there are. I saw in the documentation that there are some function to do so. So if you build, if you abstract your component, then you can check by this function provided by the system if the device is a phone, a tablet, a foldable, whatever things Android is running on, and then you can compose your screen with the components. So if you have if you have a big horizontal room, you can place two widgets in a horizontal stack. Otherwise, you place it in a vertical stack, and you don't have to do it in XML, but you can do it in the code with an if. It's better, of course, in my opinion, rather than having in the different folder. But I'm sure that there is already documentation for this, but I don't check it yet.